I don't want to confuse them.
No, this is great, Cassie, if you don't mind. So
No, I
we're
don't
going to
mind.
work through some Ionic naming, and then we're going to share this video with the rest of the class in case they're struggling. I'm going to go through some examples, and yeah, so we'll start with the simplest example is just provide the name for an ionic compound. Okay, so let's say I throw at you MgCl2. To name it, we would just name the first part and the second part.
Magnesium.
So, yeah, magnesium.
And you don't do the prefix with this.
Right, good. I'll type it so it looks better. Let's see, magnesium. And the second part is instead of dichloride, I just have to say chloride.
And how come it's not chlorate? Like, how do I know when to do that?
So when we have an element, one element, like chlorine, nitrogen, phosphorus, whatever it is, we just add the IDE. And we call it a monatomic ion because it's made out of one atom, like the chlorine turns into chloride ion. So basically, maybe it might help to visualize what is it that I'm thinking when I see MgCl2. I'm thinking Mg2+, and then I'm thinking chloride Cl-, because remember on the periodic table we were covering the charges. I forgot what page that was, but we had a little periodic table where we were page 118. We were looking at the charges on the atoms as they make ions, page 118. And so here we know Mg makes 2+ and Cl makes -1. I'll just hold it up for the recording. So Mg is over here +2, chloride is over here, it'll be -1. So because of that, that's how I figure out that there's 2, but actually this question is asking you to name it. So I just name MgCl2 as magnesium chloride, but this is what I'm visualizing. I'm visualizing the ions and their charges and the fact that they're balanced. So the next thing would be, how would we name something like FeCl3? That should be similar, right? Name the first part.
Iron, right?
Iron, and then the second part is still chloride. But there's something weird about iron. When you look at
it's in the middle.
It's
you
in
have
the
to use a Roman numeral.
Yeah, it needs a Roman numeral because what I've highlighted here are the ions that are variable in charge. That iron can be multiple possible kinds of iron charges. So in this case, I have to figure out what that charge might be. So let's just fill in. I know I have iron with a charge, but I don't know what it is yet. But I do know I have 3 chlorides that are -1 each, because we had -1 from that. So chlorine -1, -1, -1. What must this iron be to have balanced out?
3, right?
Plus, right? So that 3+ is what the Roman numeral is.
So you figure out the Roman numeral by first knowing what the second element is and how many of them there are.
Exactly. So first I have to recognize that this is one of these metals that are variable charged. So I'll leave space for a Roman numeral, and then I need to figure out what that Roman numeral is by looking at the other element and its charge.
Okay.
And then balancing it to 0. So good. And then let's try one like you were asking, how do I know it's chloride and not chlorate or hypochlorite or, you know. So let's look at, let's choose a different one. Let's say CaClO4, and then this one needs 2 in order to balance out. So notice that I'm always going to be able to split this into 2 parts. When there's parentheses, it's nice to see this is definitely together. If I had an example where it wasn't together, I would still be able to know that even though I see 3 separate elements, I'm still going to only split it into 2 parts. These are all binary compounds, 2 parts, a positive part and a negative part. Your job is just to name each part.
How do you know on the second one to split it between the Na and the Cl and not the Cl and the L?
Because I have access, and you will have access to the polyatomic ion list. And that is going to be on your laminated periodic table, and it's also in your workbook somewhere. Let's figure out where. Usually in the back cover somewhere towards the back. It's an easily accessible one, and it's also reprinted in the chapter somewhere.
So, I see mine in the back.
Yeah, that's the one we'll use. And so we've got we have access to looking and seeing, but basically it's very easy. The first element, there's usually going to be only one thing. So I can pretty much tell after the first element, with the exception of a polyatomic ion NH4, which is the beginning of another one. So like only when you see NH4 is this in itself the unit that comes before. So if I saw something like this, NH4 ClO4, I would know to split it here because NH4 is a grouping called ammonium.
Okay.
So anyway, if you're not sure, just look at the periodic table and see if it's an element. You can cut it there. If it's a group of elements, check if it's a group of elements through this chart and back. All right, so in these examples though, notice that we have a polyatomic ion, ClO4. So we will look up what is ClO4 called. And you'll see ClO4 minus is called perchlorate. And notice it's different from ClO3, ClO2, ClO. They all have slightly different names. So this is called perchlorate. And maybe you've heard of perchlorates being in foods and, you know, like spinach and lettuce, and people taking care to rinse that stuff off because it's used to, oxidize and, you know, keep, it's used in processing. So then we have calcium. So we have calcium perchlorate. That's it. We figured out what two things we need to name. Here it would be sodium perchlorate. And here we have ammonium perchlorate. All right?
Okay. And can you remind me, by looking at like that ClCl, O4, or one of the covalent molecules, how I can tell just by looking at them without, there being a title that says ionic naming or compound naming? Like, again, remind me how I would know.
Yeah. So the ionic, really good question. So the covalent molecules, like we were sort of talking about water, we generally have elements that are nonmetals on this side of the periodic table. When they bond together, they tend to be covalent. When we have atoms like from this side called metals, and we have something from over here called nonmetals, they're from opposite sides of the periodic table. One side tends to become positive ions, these tend to become negative, and then I know that I have ionic. So to summarize, I would say how you know if you have something covalent or ionic or covalent, question mark. I would look and see if you have a metal and a non-metal, they're gonna have opposite charges, and it's gonna likely be an ionic compound. If you have a non-metal like oxygen bonding with another non-metal like hydrogen, remember hydrogen's on the left side of the table, but it's still considered a non-metal, you're probably gonna have sharing of electrons because they're not opposite charges. So they're gonna share. So you're gonna have covalent molecules.
And what if you have a mixture like that NHClO?
Yeah, here there's some, that's an exception because NH4 acts like it's gonna act like a positive charge. It is a positive charge.
Okay.
So that sometimes nonmetals can get together and take on positive charge. So then they can bond with things that are negative, and these get together and form a negative. So anytime you have ammonium, that's gonna be your exception to that rule.
Okay.
Okay, good. So, and then the other examples I would work through then are simply going backwards. Like if I have titanium 4 oxide, being able to come up with the formula for that, So titanium 4 is Ti4 plus, oxide is O2 minus. So how do these come together to form a neutral compound?
You're going to need 2 oxygens. So
I need 2 oxides. So it has to be TiO2.
Hmm.
So that's the other part of it. And I can complicate it by, yeah, having something with the Roman numeral, which I threw into this example, or I can even do a polyatomic ion, like maybe
Those
I'll
are hard.
do, yeah, maybe I'll do like copper 2 sulfate. Okay, so now I know I have sulfate, not sulfide. Just FYI, sulfide is this, sulfite is this, and sulfate is this. Again,
and I can look at my
yeah,
polyatomic to know that?
absolutely. You're going to have this. So you can simply look up sulfate. You see that this is what sulfate is. Copper 2, what's that?
Just copper 2, right?
Yeah, copper 2 plus. Roman numerals are always positive.
Okay.
Okay. So I have a copper 2 plus and a sulfate, which is 2 minus. So what's that going to be when it gets together? Cu SO4. I just need one of each to balance out.
Oh, because the 2 and the 2 cancel out.
When the 2 cancel out.
Okay.
Yeah, and then in class we talked about the crisscross rule, but I forgot to tell you, when you crisscross these, you will end up with 2's, which cancel out. So you should use the smallest, you should cancel them all the way down to the smallest common denominator. Right. Yeah, so this should be CuSO4. But yeah, I mentioned the crisscross method because that's a really easy way of coming up with these answers. All right?
Okay.
Okay.
Awesome.
Yeah.
I think I'm good. Yeah. I'm trying to see if there's any examples in the